Welcome! Today we're going to be working on lesson 0A.1, which is going to be multiplying exponents. Our content objective is students will be able to simplify expressions with exponents that are positive and zero. Our language objective is students will be able to explain in words the process of simplifying exponent problems. Why am I learning this? Well, it's important for real-world problems like representing the size of something very small, such as the diameter of a white blood cell. Okay, so first let's go over some basic things. First, we need to remember this here is what we consider exponential form. We would read this as 3 to the 4th power. The base would be the 3. This is the larger number that you see. And then the smaller number at the very upper right hand corner is referred to as the exponent, or sometimes referred to as the power. So in other words, base is the number that you repeat, and the exponent tells you how many times to repeat that base. So here, the power of 4 is repeating the number 3. So 3 is repeated 4 times. Here is what we're going to refer to as an expanded product. Okay, so here, if we multiply it all out, 3 times 3 is 9. Here, 3 times 3 is 9, so 9 times 9 is 81. This would be our evaluated answer. So in the instructions here, it says rewrite as expanded products and then evaluate. So here you're going to write it out as an expanded product, and then you will simplify it and have it evaluated into one number. So what I'd like you to go ahead and do is pause the video and try numbers 1 through 4 on your own. Okay, so let's see how well we did. So here, what is being repeated 2 times? 5 is. So exponent is repeated multiplication, so notice we repeated 5 2 times. So this is our expanded product. 5 times 5 is 25. So this is our evaluated answer. Number 2, what is being raised to the 4th power? 2 is. So I'm going to repeat 2 a total of 4 times. And then I'm going to go ahead and multiply it out to get our to evaluate the answer. So one thing is some students are going to be tempted to just multiply straight across. If it is easier, you might want to pair up numbers like this. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. The same way here, you notice I did 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. Versus saying 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So just something to consider. So here, to finally evaluate it, 4 times 4 is 16. So that is the final answer once it's evaluated. Now let's look at number 3. What is being repeated 4 times? Technically, a negative 3 is being repeated 3 times. So our base is a negative 3. So I'm going to go ahead and repeat the base of negative 3 a total of 3 times, which looks like this. Now, personally, what I like to do is consider, is my answer going to be negative or positive first? So here, a negative times a negative is a positive. So I'm just going to go ahead and do this to kind of let myself know that I've worked with that. And then a positive times a negative is a negative. So my final answer is going to be a negative number. 3 times 3 is 9, times 3 is 27, so that leaves me with negative 27. Now, moving on to number 4, what is being squared? Well, a negative 9 is being squared because our base is a negative 9. So repeating negative 9 2 times, a negative times a negative is a positive. 9 times 9 is 81. So there is our final answer, and that is evaluated. Okay, now moving on. So some vocabulary. Exponential form, once again, is basically when you have a base raised to an exponent, or aka a power. So here 2 to the 5th is exponential form. An expanded product is when you take that base and repeat it as many times as the exponent tells you to. So here I'm going to repeat the base of 2 a total of 5 times. And once again, please remember that exponents is repeated multiplication, which is why we put multiplication in between every single time, versus addition or subtraction. And then evaluate means you're just going to go ahead and simplify it completely by multiplying the numbers out. So here 2 times 2 is 4, 2 times 2 is 4. I'm going to go ahead and do 4 times 2, which is 8, and then 8 times 4 is 32. So once again, feel free to group them. Going in order straight across might not be your best method, but it will still work. So here, evaluate is going to be 32. So let's look at the powers, how we can phrase it, and what it means. So here, the power is a 2. The way you would read it is 7 squared, or 7 to the second power. Okay, so there's 2 ways to read it. What it means is the base of 7 is repeated 2 times. Here, I can read this as 5 to the third power, or you can say this as 5 cubed. What does that mean? Once again, your base is going to be repeated a total of 3 times, like so. So it means 5 times 5 times 5. Once again, it's repeated multiplication, so that's why we separate each number with a multiplication sign. Okay, so now what I want you to do is, knowing these concepts, I want you to go ahead and rewrite number 5 and 6 as an expanded products, and then go ahead and evaluate it. Okay, so let's see how well we did. For number 5, what I always do first is ask myself, what is being squared? Well, it is a negative 2/5. So I'm going to go ahead and write negative 2/5 2 times, because it's being squared. Once I do this, again, I like to look at the negative signs first. I want to tackle that before I move on to actually multiplying. A negative times a negative is a positive, so let's just go ahead and change that. And then now I know my answer is a positive. So here, multiplying straight across, 2 times 2 is 4, 5 times 5 is 25. So it's a positive 4/25. Now, once again, what is being cubed? Well, it's a 3/7. So I'm going to go ahead and repeat 3/7 3 times. Notice I put parentheses. For me, a general rule is if it came with parentheses, I'm going to put it just to be safe. Now, was it necessary for this particular number? No, because it was positive. But a safe bet is if it came with parentheses, use parentheses. It's not going to hurt. It might just cause hand cramps from rewriting everything so many times. Okay, so now there's no signs to deal with, so I can go ahead and multiply straight across. 3 times 3 is 9, times 3 is 27. 7 times 7 is 49, times 7 is 343. So my final answer is 27 over 343. Now, one thing I forgot to mention that is extremely important is before I went ahead and boxed my answers, it's important to check, are these fractions reduced? Fortunately for me, they were. Now, it's important for you to make sure you do that in future problems because you might actually have to reduce them. So keep that in mind. Okay, so now multiplying with the same base. So what if we're given something a little bit more complex, such as 4 cubed times 4 squared? Well, how could I do this? Well, I'm going to revert back to my basics. Before, in the past, I've rewritten everything as expanded products to figure out what it means. I'm going to go ahead and do the same thing here. 4 cubed means 4 is repeated 3 times. Okay, we're going to multiply it 4 3 times. Okay. 4 squared means I'm going to repeat 4 2 times and multiply that, so 4 times 4. Now this is my final answer. Well, guess what? There's a more simplified way of rewriting this. Okay. In other words, it's 4 repeated how many times? Well, let's see. 1, 2, 3, 4, 5. So I'm going to go ahead and say that this is 4 to the 5th power because the base is a 4. That's the number that's being repeated. How many times was it repeated? 5. Now, some of you, let's face it, will see a shortcut or a trick or a pattern. You might want to stick with that. But what I encourage you to do for the first few weeks or so is go back to the basics of expanded form and do that instead because sometimes your patterns may not translate correctly. So please just practice expanded forms for a while. So there's my exponential form. That's the answer. Okay, so we're going to go ahead and rewrite as a single base and exponent. So again, I encourage you to write everything as an expanded product. What does it look like? And then simplify it into one exponential answer. Okay, so for number 7, what is being repeated 4 times? And -2. So I'm going to go ahead and write -2 4 times. There you go. And then here, what is being squared? Another -2. So I'm going to go ahead and write -2 2 times. So how could I write this answer in a more simplified way, more condensed? Well, I can write a -2, That's repeated 1, 2, 3, 4, 5, 6. So I'm going to go ahead and write negative 2 to the 6th. Notice I put parentheses. Why? Because without those parentheses, it would look something like this. And notice before I said what is being squared at negative 2. If I repeat this process, what's being raised to 6th power, it would technically be a 2, not a negative 2. So is this a correct way to write it? No. It is important to understand whenever you have a negative base, it is necessary for you to include parentheses around that base. Without it, it's no longer a negative base. So please remember that. Number 8. Here, what is being squared? A 3. So I'm going to write 3 squared. Okay, it's 3 times 3. Now here, it's just 3, so I'm just going to go ahead and copy down a 3. So in other words, it's 3 raised to the 1st power. So how can I rewrite this in a condensed form? Well, it's 3 being repeated 3 times, so I'm going to write 3 cubed. So notice here, it wasn't necessary to put parentheses because our base is positive in this case. Number 9, what is being squared? It's a 1/2, so I'm going to write 1/2 2 times. Here, what is being cubed? A 1/2, so I'm going to go ahead and write a 1/2 repeated 3 times. So how many 1/2s do you see? I see 1, 2, 3, 4, 5. So I'm going to go ahead and write 1/2 raised to the 5th power. Now, if you remember from previous slides, I said if it has parentheses, safest bet is to keep those parentheses around the base. And it was safe here, and it was safe here. Why? Some of you might be tempted to write it without the parentheses. Is it wrong? Well, let's think. What is technically being raised to the 5th power? Just the 1. So essentially, this means 1 times 1 times 1 times 1 times 1 over 2. The only thing being repeated is the 1 5 times. So does this look like this? The answer is no. So are these answers the same? Absolutely not. Please make sure if it's a fraction, you keep parentheses around the fractions. So we've learned 2 things. If your base is negative, make sure you have parentheses around them. If your base is a fraction, make sure you have parentheses around them. But what's your safest bet? If it came with parentheses, keep the parentheses. Okay, so now we're going to go ahead and start writing expanded products in exponential form. So let's take a look. Here we have an expression, negative 2 times negative 2 times negative 2 times negative 2. How do I write this in an exponential form? First, you should be asking yourself, what is being repeated? It's a negative 2. Do negative bases need parentheses? Yes. So we're going to go ahead and write a negative 2 with parentheses. Since it's being repeated 4 times, I'll write negative 2 to the 4th power. And again, safest bet, if it came with parentheses, keep them in your final base. Okay. So now I want you to go ahead and pause the video and try number 10 and 11 on your own. So for number 10, what's being repeated? 7. Okay. Well, how many times is 7 being repeated? 1, 2, 3. So I'm going to write a 3. There's your final answer. Number 11, what's being repeated? A negative 8. How many times? 1, 2, 3, 4. Could I write it like this? The answer is no. Okay, remember, the base is a negative 8. How do I indicate that? By using parentheses, by showing it's a negative 8. If you wrote it like this, what it means is what's being raised to the 4th power? 8. So 1, 2, 3, 4. And then you simply bring down the negative. This is not the same as this. So once again, is it okay to leave out the parentheses? No, it would be wrong. Okay, so now let's look at some special exponent problems. So here we have the opposite of 4 cubed. Notice I didn't say negative 4 cubed. I said the opposite of 4 cubed. So essentially, what is being cubed? Just the 4. So I'm going to go ahead and cube the 4, but leave the negative on the outside. I went ahead and put parentheses here just to kind of show the group of 4s. Is it necessary? No, just kind of makes things a little bit cleaner. So now, if I wanted to evaluate this, I would do 4 times 4, which is 16 times 4, which is 64, but then I have to still multiply it by a negative. So my answer would be a negative 64. So please, make sure you understand it's not the same as negative 4 cubed, okay? It's totally different. Now here, again, is this negative 6 squared or is it the opposite of 6 squared? Well, if it was negative 6 squared, there'd be parentheses around it, so I can clearly see that the base is negative. But it's not. So you would read this as the opposite of 6 squared. So here, we're going to write it as the 6 being squared and keep the negative on the outside. And here, 6 times 6 is 36, times a negative, negative 36. But even if you read it out loud, the opposite of 6 squared, what is 6 squared? 36. What's the opposite of it? Negative 36. So it's very beneficial to read it correctly as well. So please make sure there's a difference between when there is parentheses around the negative number and when there isn't one around the negative number. Okay, so now I would like you to go ahead, pause the video, and try numbers 12 and 13 on your own. For number 12, hopefully you went ahead and understood that that was the opposite of 5 squared. So you went ahead and put the opposite and then squared the 5, giving you negative 25. And you also understood that for number 13, it's negative 8 squared. So you went ahead and squared the negative 8, giving you a positive 64, because negative times negative is a positive. So please, once more, you can see here, the only thing being squared is 5. And here, the thing that's being squared is a negative 8. You can clearly see it here. This, it's not. Okay, so please make sure you know the difference. So now go ahead and pause the video and try the next two on your own. Okay, so let's see how well we did. For number 14, what is being squared? It's going to be a 2/5. So I'm going to go ahead and write 2/5 squared. But notice I went ahead and just dropped down that negative. That negative wasn't squared as well, only the 2/5. So here, multiplying within the parentheses, you're going to get 4 over 25. But you still need to multiply by that negative, so we got negative 4 over 25. Here, what's being cubed? Just a 3/4. So we're going to go ahead and cube 3/4. But notice we went ahead and just dropped down that negative. We can go ahead and multiply the fractions on the inside. 3 times 3 times 3 is 24. Sorry, not 24, 27. 4 times 4 times 4 is 64. So you still need to multiply by negative, so we get left with negative 27 over 64. Are both of these answers reduce? The answer is yes. So please make sure you reduce if ever possible. Okay, so now go ahead and pause the video and try the next two on your own as well. Okay, so let's see. Number 16. What is being squared? Just a 3. So this is not negative 3 squared. This is the opposite of 3 squared. So what is 3 squared? 9. What is the opposite of that? Negative 9. Okay? But, excuse me, I kind of went ahead of myself. I didn't read the instructions. It does say rewrite as a single base and exponent. So they don't want us to evaluate it and get a number. They want us to write it as a single base and an exponent. So here, I'm going to go ahead and write this out as a negative 3 times 3. I'm going to bring down that bring down that 3 to the first power, which is just 3. So how could I write this? Should I write a negative 3 in parentheses? No, I'm going to leave the negative on the outside, and I'm going to say, look, 3 is repeated 3 times. So note, it should not be written like this. Okay, that is technically incorrect. Okay, number 17. Here, what is being squared? 1/2, so let's write that out. 1/2 repeated 2 times, keep the negative on the outside. What is being cubed? 1/2, so let's go ahead and write that out one more time. So how many halves do we have? We have 1, 2, 3, 4, 5. We have 5 of them. Now, is it necessary to put the fraction in parentheses? Yes. Remember, it's mandatory to keep negative bases in parentheses as well as fractions. So here, I'm going to go ahead and write the opposite of 1/2 to the 5th power. Remember, it's not a negative 1/2, it's the opposite of 1/2. It's negative only if it's on the inside of the parentheses. Okay, so now go ahead and continue practicing by doing number 18 and 19. So at this point, I'm just going to go ahead and review the answers with you. Number 18, the answer is the opposite of 7 cubed, because notice it's just a 7 that's being repeated, not a negative 7. Here, we're going to notice that our base is a negative 8, repeated 4 times, but this negative out here tells us we are going to have to do the opposite of that. So it's going to be the opposite of negative 8 to the 4. So this one's kind of tricky, so be very careful. Make sure you have the correct answer there. So that is actually going to conclude the lesson for today. Thank you so much for tuning into this screencast. Hopefully you've learned and reviewed how to work with positive exponents with multiplication. Again, thank you so much for tuning in, and until next time, bye!